Okay, let's look at the Riemann sums, right? It's very similar to left sum and the right sum. It's just that instead of using left endpoint or right endpoint, you're gonna use any point on that interval, right? So let's look at this picture, right? Let's say this is a graph of y equals f of x, right? And we want to approximate the area under the curve from x equals a to x equals b. So it's right here, right? Then if you're doing the right sum, all you do is using the right endpoint. So we're gonna divide the interval from a to b into n subintervals, and I'm gonna label it a is x0 and next one is x1, x2, x3, all the way to xn. So in general, right sum is going to look like this, right? So we're going to plug in the right endpoint. So for the first rectangle, we use x1. So this is going to be just f of x1 plus f of x2, and you just keep on going, plus f of xn, so that's the last one. Then you multiply by delta x, right? And there's something called a sigma notation that we can write this in a shorter notation. So here's a sigma notation, right? Sigma basically stands for sum. Then k value is gonna start from 1 to n. So k value represents this indices. So each term is gonna have f of xk, then times delta x, right? So start with k equals 1. So you have f of x1 delta x, which is this guy, f of x1 delta x. Next one is f of x2 delta x. Next one is f of x3 delta x, and so on. Then last one is f of xn delta x. Right? So this is the right sum. Right? The Riemann sum is going to be it's not going to be the right endpoint. We're going to use any point in between. So for example, for the first one, so you have that. For this first interval, you pick any value, let's call this guy C1, right? And use that value to determine the height of the rectangle, right? So that's going to be our first rectangle. And any value between x1 and x2, there's going to be C2. And use that value to determine the height of the rectangle, right? Then you just keep on doing that. So last one would be Cn. So that would be a rectangle which looks kind of like this. All right. So the sum is going to look like this. Instead of f of x1, you're going to have f of c1. Then next one is, of course, f of c2. And so on. And then you have f of cn times delta x, right? And which can be written in summation notation. Summation, k goes from 1 to n. You have a f of ck delta x, right? Maybe where, right? ck is always in, maybe I should use the notation, ck is always in the interval between xk minus 1 and xk. Right? This is called the Riemann sum, and notation is S sub n. Right? So let's look at a small example here. Right? Let's say your function is 16 minus x squared, and the interval is from -2 to 4. And the ck is actually the midpoint between these two endpoints. All right. So let's find the delta x. So you have delta x is going to be equal to, right? So if b is 4 minus a is -2, right? Divided by number is in this case 3, number of interval 3, right? So that's 6 over 3, so it's 2, right? So interval is split into subintervals this way. So let's say you are going from -2 to +4, right? And this is split into 3 equal intervals, so that's going to be 0 here and 2 there, right? But the ck is the midpoint of the endpoints, so c1 is going to be right here. That's going to be c1, and c2 is going to be right here, and c3 is going to be right there. And you can see that that's a midpoint of -2 and 0, so it's -1 there. And midpoint of 0 and 2, 1. Midpoint of 2 and 4, so that's going to be 3 there. Right? So what you do is to find the Riemann sum, and with 3 rectangles, would be you have f of, right, c1 is -1, plus f of c2 is 1, plus f of c3 is 3, then multiply by delta x, which is maybe I'll write the delta x for now, so which is going to be 2, right? So this is going to be equal to, right, plug in -1 here, 16 minus 1 squared, so it's 15, plus plugging 1 there, it's another 15, and plugging 3 there, so 3 squared is 9, so it's 16 minus 9 is 7, right? Then you have to multiply by 2, right, which is going to be equal to 37 times 2, which is equal to 74, right? So this is the Riemann sum, right? So you're just using the midpoint of each interval. Alright, that's it. I hope that this was clear.